Hi, welcome to video 4.2, 4.3b, more on Riemann sums. Okay, so this is the worksheet. Is that it? No, that's not it. Oh, that is it. No, that is not it. This is the worksheet. Okay, so on the worksheet, we're looking at number 5. So just to kind of talk about the worksheet a little bit, you're approximating the area. You are not asked to find the exact area, which would be the definite integral. That's not what you're asked to do. You're asked to approximate the area. The regions are bounded by f of x, which you're given, the x-axis, and the lines x equals a and x equals b. You're going to divide the interval from a to b, 0 to 2, -1 to 2, into n subintervals of equal length. So that means your dx's are all the same, your widths of your rectangles are all the same, and the n is given to you right here. So 4 rectangles, you're going to split that distance between x equals 0 and x equals 2 into 4 rectangles of equal width. You're going to use the area of the rectangles created as indicated. Now the 5 choices are either inscribed, circumscribed, left endpoint, right endpoint, or midpoint, and they have to tell you which one you're using. And round your answers to 3 decimal places. Okay, so each one of them will tell you what kinds of rectangles you're using. So we're looking at number 5. F of x equals 4 cosine x. So that's what it's bordered on the top by. And I'm going to tell you right now, all of these functions are above the x-axis for x between a and b in each case. So it's bordered on the top by f of x equals 4 cosine x, on the bottom by the x-axis, on the left by x equals negative pi over 2, on the right by x equals pi over 2. You want to use 4 circumscribed rectangles of equal width. Okay. So here's the graph. Of course, here's the graph of y equals cosine x, and we're looking at it between negative pi over 2 and pi over 2, so it's this region right here. Okay, so we're looking to find the red region. Now we're going to take that and we're going to divide it into 4 rectangles. Your delta x, the formula for delta x is always the same, and your delta x is this quantity right here, because you're taking the distance between A and B and you are dividing it into 4 equal parts in this case. So B minus A is what the distance is. B minus A is pi over 2 minus negative pi over 2, which is pi, and then you divide that distance in 4 equal parts, pi over 4. So the width of each rectangle is pi over 4. So starting at the left, you're going to add pi over 4, add pi over 4, add pi over 4, add pi over 4. Now, at each of these points, at the end point here, which is on the x-axis, and that's on the y-axis, and that's where the curve is. But from each of the others, you're going to go up and touch the curve. So these green lines come from these at the end points of each of the rectangles' widths, and you're going to go up to the curve. And then each of these rectangles has to be circumscribed. So starting over here, circumscribed means the rectangle has to be bigger than the area under the curve beneath it in all cases. Well, that's going to happen at the highest point on that interval, which in this case happens to be right endpoint. So here's your first rectangle. The next one is also increasing the whole time until it gets to the right, so it's going to be a right endpoint again. But in the other cases, between 0 and pi over 4, the highest y value is at the left side of the interval, which is left endpoint. And then same thing here, between pi over 4 and pi over 2, the highest point would be at the left endpoint. So there's your 4 rectangles, and now you're going to add up their areas. Now, the area of the entire region is approximately equal to the sum of the areas of those 4 rectangles. Because they all have the same width, I'm just going to pull that width on the outside, and then times the height of the first rectangle, which is f of negative pi over 4, the height of the second rectangle, which is f of 0. Now it turns out the height of the third rectangle is also f of 0, and of course the last one, the height, is f of pi over 4, and f of x being cosine x, and then you evaluate all of those different pieces and you get 10.726. Okay, now there's what's called the lower sum, which is what your book will call inscribed rectangles. The upper sum is the circumscribed rectangles, and of course the actual area is between the lower sum and the upper sum. 5 types of rectangles: left endpoint, right endpoint, midpoint, inscribed, circumscribed, also known as lower and upper. So here's left endpoint. The blue area is what we're trying to approximate, and we have 4 rectangles of equal width. This first one shows you left endpoint, so for each rectangle you go to the left, up to the curve, and that's where the height of the rectangle is. Next interval between 2 and 3, go to the left side of the interval, go up to the curve, and now draw horizontal and come back down. Okay, right endpoint, you're going to go to the right of the interval, and now that's going to be your height. You're going to go to the right of the interval, that's going to be your height. Midpoint simply means at the midpoint in between, at the middle of each interval. So halfway between 1 and 2 is 1.5. From there, you go up to the curve, that's your height. 2.5, go up to the curve, that's the height of your rectangle. Okay? Inscribed, of course, has to be under. Notice in this last piece between here and here, the lowest spot is not at the left end point or the right end point. It's at whatever that relative minimum point is, and that's the height of your rectangle. Circumscribed is above. Okay, so here's an example: y equals x minus 2 squared. It's so you have a region bordered on top by that function, on the bottom by the x-axis, on the left by x equals -1, on the right by x equals 3. We're going to do 4 rectangles of equal width that are left endpoint. So we draw the curve. Of course, this is y equals x squared, move to the right 2. So it looks like this black curve right here. We're going from -1 to 3. So here's -1, here's 3. Go up to the curve, go up to the curve. And we're going to find our dx. We're going to take our b minus a, which is 3 minus -1, divided into 4 equal parts. And that means the width of each rectangle is 1. So starting at the left, -1 plus 1 is 0, plus 1 is 1, plus 1 is 2, plus 1 is 3. At each of these spots, go up to the curve. Go up to the curve, go up to the curve, which is actually the x-intercept, and go up to the curve. Now, we're doing left endpoint, so for each interval, no matter who's highest or lowest, we're going to the left. Go up to the left side, there's your height. Between 0 and 1, go to the left. Go up to the curve, that's your height. Between 1 and 2, go to the left. Go up to the curve, that's your height. Now, interestingly enough, between 2 and 3, we're going to go to the left, up to the curve. It turns out that our f of 2 is 0, and that's just the way life happens. So we have a common width of 1, which I pull on the outside. First rectangle's height is f of -1 plus f of 0 plus f of 1 plus f of 2. And of course, here's your f of x that you'll be plugging these x's into. And you'll get 14. And that's the end of video 4.2.4.3b.